Welcome to Spring LIB.
7.35. So we have a spring with a spring constant of 65 newtons per meter. So what we'd like to do is draw a graph of the force versus distance, and then find the work if we take the spring and stretch it from 3 centimeters from its equilibrium position to 6.5 centimeters. So let's start by sketching the force here. We know that for a spring, the force is just directly proportional to the amount of stretch or compression by the constant of proportionality is the spring constant. So if we have x1 and x2 is our 3 and 6.5 centimeters, then our force will be kx1 and kx2 here. And so the work, if we have a plot of force versus distance, is the area under that curve. In this case, the curve is a straight line. So this is a trapezoidal region, and we can compute the area of it pretty easily. If we didn't know this, we could, or if it weren't some shape that's easy to compute, we could directly integrate it, but we don't need to in this case. So we just use what we know from geometry about the areas of trapezoids. And that will be equal to the work. X1. And so then all we need to do now is put in the numbers for this, and you want to make sure to, for x1, for example, needs to be 0.03 meters, so that you get units of joules. So otherwise you'd have Newton centimeters per meter, and that's not really a standard unit of energy, so you don't want to do that. So being careful about the units, we find that this takes 0.11 joules of work.